This week, we're going to start looking at sky motion. Now, as part of the sky motion lab, there's some introductory material. I'm going to quickly go through and look at some of those pages, show you some of the animations within those pages, and walk you through some of the flash simulations we used for this week's lab. So in each one of these background pages, they often have, in addition to some introductory material and vocabulary words, little simulations that you can go through and play with. So in this one, I can click and drag this star and change its coordinates. So the coordinates here that they're referring to, the one marked by the red line, which starts here at the northernmost point, is known as the azimuth. This blue one right here is known as the altitude. So altitude is how high up in the sky an object is. Azimuth determines what direction. And we can click here and see labels for some of the very important terms that you'll want to go through and learn. There are also different views that we can go through and look at. We can look at things in what's known as the celestial sphere view, and I can spin all of this stuff around. So this little dot represents where you are. And I can go through and switch it to what's known as the horizon diagram, something that looks more similar to what we just saw, which is what you would see if you were at that location. Again, with our cardinal directions north, east, south, and west marked. We can spin this around to be able to see things a little bit better. We can also go through and change the latitudes. This is northern hemisphere. Negative numbers correspond to the southern hemisphere. Now, some of the things that you're going to go look at while we're going through this week's lab are how stars move. So I can add some stars here. I can start to animate things so that we can see how they move in our sky. We can move things around. So you'll have lots of questions that'll go through and have you play with some of these things and see how things move, both for your location and for other locations as well. So if I pause this, reset the star trails, and change my latitude to something different, I can see how they go through and move around differently depending on the latitude that I happen to be at. There are certain areas where objects move. So the sun, for example, is always going to be in this range of the sky for this latitude of 41. But if I change the range, we can see where we expect to see the sun is different. And same goes for the moon and planets. So all of those were the introductory material to get you to this simulation, which we can see combines many of the different things that we were able to go through and look before. So this rotating sky explorer consists of a flat map of the Earth, the celestial sphere view, and a horizon diagram. And all of these are linked together. So if I move my position here on the flat Earth map, we can see that everything adjusts on each of these diagrams. I can also directly enter numbers in to go to a very specific location. So this is roughly where our school is based on the activities that you went through and did before. So we can click and drag any of these pieces to change our view. We can change the map cursor on the flat map to be able to go through. You can also use the arrow keys on your keyboard to change your latitude and longitude, and doing so always changes it in 5-degree increments. So you can see I've been changing the latitude, and I can work myself down in 5-degree increments back to the 34. And I can do the same for longitude by using my left and right keys, again in 5-degree increments. I can also add stars to my screen, just like I did before. I can add a star randomly, and if I just keep clicking, I'll see them appear. So again, we'll see them pop up on the celestial sphere. I can also move them on the celestial sphere to specific locations if I want. On the celestial sphere, we see a different coordinate system. The one marked by the yellow line that I'm changing right now, that one is known as the right ascension, and the orange one marked by hours is declination. And we can see how that changes the view for the person here. So we can go through, and again, they're marked down here if you want. You can enter directly in here to make it go to a specific position on the celestial sphere, or you can change your altitude and azimuth here to make it go to a specific position in the horizon view. We can do star trails as well. We can animate and watch them move around. I can decide to show labels or not show labels. I can take away the underside of the horizon diagram if you don't like seeing that view, as well as label some special places on the diagrams. So you'll go through and utilize all of these various pieces to go through and do the first part of your lab. For the next one, again, there's another introductory piece. So we can go through and see how the sun moves in our sky throughout the year. Now in this particular one, it's showing us the sun at noon, and we're just changing the day. So it's as if you took a snapshot at noon every single day and looked at how high up in the sky the sun was. And we can stop this at any point. Down here, we can go through and play around with how the angle of the sunlight that comes in, which is determined by how high in the sky it is. If the sun is low down, then I would expect a lower angle, something more like this. If the sun is very high in the sky, I would expect a more direct angle like this. And we can see how the intensity of that sunlight changes. So this view right here shows essentially how much that sunlight is spread out when it hits the ground. So when the sunlight is coming in very directly, that's a very small but intense area. And if it spreads out, you can see it becomes much more diffuse because that same amount of sunlight is being spread over a much larger area. So it's not nearly as bright. In the second part of the lab, you're going to utilize this idea of the directness of the sun's light and combine it with images and simulations of the Earth going around the sun to be able to understand more about the seasons. So in this one, we can go through and do similar sorts of views and controls. So here we have the orbit view that shows both the Earth and the sun. The arrow shows the sunlight hitting Earth. The shaded part here is the part of Earth that's not receiving any light. I can also switch this to the celestial sphere view, which has the sun in the center, or excuse me, the Earth in the center and the sun orbiting around. And then that point right there corresponds to the person, to where the sun is most direct. And then I can move my person. You can see that red line changes on both the celestial sphere view, and it also changes the angle of that sunlight that we see. That little white dot there is known as the subsolar point. So that's the place where the sunlight is going to be most direct, and it's here in this view as well. You can take that away if you decide to. Again, we can put labels on our graph, and this is the position of the sun in our celestial sphere view. We can put labels on this one as well in case that helps showcase some certain areas, and these green lines correspond to special points. As I move my person here back and forth, we can see that that latitude changes. And for some of the activities you're going to need to do for this part, you're going to need to be able to make very fine adjustments to that person. So if you click on that person and then move your mouse far away, you can make much finer adjustments. You can see I can just barely change that by a small fraction of a degree, whereas if I'm close in, if I do any sort of wiggling, I'm changing it by a lot. I can change this view as well. So this is the view from the side, and I can go through and take a look at what it looks like if we were on the sun looking at Earth. So now in this case, it doesn't matter where I move Earth, I'm always going to see the sunlit side, because if I'm the sun, I'm going to see that sunlit side. You'll probably utilize this view most often. And lastly, we can switch between the sunlight angle view and the sunbeam spread view, just like in the last introductory page. We can grab this red marker down here and change the time, basically when during the year you want to see. You can see I'm making it reverse now. I'm making it go forward in time so we can go through and see how Earth orbits the sun there and how that sunlight changes for that latitude. I can just let it play and watch it over time without having to drag it. That is also okay. And again, if I move this little person, we can see that latitude change. You can't make it go to the left side of Earth, but again, remember, Earth here is rotating. We're just looking at what it looks like on a particular time. But since Earth is spinning around here, just because it's showing nighttime on this side doesn't mean that the sun won't ever get there. That changes, of course, over 24 hours. The final part of the lab will again start to look at the path the sun takes. So this is very similar to one of the ones we saw before. And you can play in with the various different steps and changing your latitude to see how that affects things before you move on to the very last part, which brings in time of day as well. So this one was looking at just a specific set time. This last one will actually start to look at time of day. So we can directly change the the day. I can directly change the month to go to a very specific month. I can change the time to go to any time that I want. And you can see as I'm going through and doing those changes, everything updates. So down here, the information box tells me exactly what latitude I'm at, what date and what time I happen to be looking at it. And it's giving you both the 24-hour time and the regular 12-hour time that we're more used to. Down in here, it's showing me some more information, which you probably won't need. But the other important parts here are the sun's altitude and the sun's azimuth. You'll need those as you're going through and looking at what's going on. We can spin the diagram around, again, any way that you want. You can move the sun. You can see how that changes the time. You move this to go to a different latitude, or I can type directly in here to go to a different latitude. Everything updates for me. I can make it animate so I can see it go through. I can change the animation speed if that's too fast for me, if I want it to go slower. And if I want to watch the motion over the same day over and over, I can loop that day so that it doesn't move into the following day. Otherwise, just as time moves forward, once you go past midnight, you're now in the new day. If you're having problems animating because of internet issues, you can click this box and it'll make it slightly lower quality graphics, but so that it's not pulling as much data for you. And that should improve any sort of skipping that you may see. There are other things that we can change through here as well. So we can take some labels on and off. The ecliptic is the path the sun follows, so we could take that on and off. I could add months, which basically corresponds to where the sun should be on the ecliptic based on the time of year. So right now we've got this set for June 21st, so that's why we see it in the June section. Again, I can hide the underside of the celestial sphere if I want. And I can hide my little stick person in there and its shadow. Another thing that's nice to see is how that shadow gets longer and longer when the sun is closer to the horizon versus shorter when it's higher up. And lastly, what I just did by dragging the sun, right now I've got it set to, when I drag the sun, it just changes the time of day. But I can change that to day of year. So now when I drag the sun, it's actually going to change the date instead of the time. It's going to keep the same time, but it's now changing the date. Most of the time you would probably want it to be time of day, but you do have that option to go through and change things. So hopefully this video helped orient you into the different simulations that you'll use for the Sky Motion Lab. And please don't hesitate to reach out if you have any questions or if you're having any trouble with anything.